morning, physics kids. One more video on momentum and how to solve for the problems. And this is a more general idea. This is what I term pin equals pout. And really it's P in equals P out. The momentum coming into a situation must equal the momentum coming out of a situation. So if you have a problem that does not clearly fall into the elastic or inelastic situation, use pin equals pout. Just jump right into it. It's not very hard. It's a kind of a neat system. Let me show you how it works. All right, so we have a situation here. We have a 2 kilogram mass moving at 5 meters per second. What is its momentum? Right, well, we know momentum is mass times velocity. So 2 kilograms at 5 meters per second would give an initial momentum of 10 kilogram meters per second. Let's look at the next one. 3 kilograms moving at 13 meters per second. Put that together, we see that that is going to the right at 39 kilogram meters per second worth of momentum. So these two things collide. So if they bounce off, you might be tempted to say, well, it's going to be an elastic collision. Let's see. If it's an elastic collision, we know that this 39 kilogram meters per second must be down here. All of it's transferred to this one. Is it? Well, look at what we have. 2 kilograms moving off at 8 meters per second. Okay, put the momentum together. That is a momentum of 16 kilogram meters per second. Clearly not 39 kilogram meters per second, so it must not be dealt with as an elastic problem. It must be dealt with as a pin equals pout problem. So, what do? Pin, P in, how much momentum is coming into the system? Let's look at that. All right, so if we're doing that, we have 39 kilogram meters per second is to the right, so that's positive. 39 kilogram meters per second. This is negative, so minus 10 kilogram meters per second. That gives us 29 kilogram meters per second. That is the momentum coming into the system. So what we do is we set this right here, 29 kilogram meters per second must equal 16, this is also positive, this 29, positive, so might want to mark those, 16 kilogram meters per second. 29 kilogram meters per second equals 16 kilogram meters per second. No, it doesn't. It equals 16 kilogram meters per second plus what? What are you missing? So plus x. So how do you find the value of x? A little algebra. Minus 16 kilogram meters per second. So x then must have a value, x must have a value of 13 kilogram meters per second, and that's going to be positive. So we put over here, positive means it's going to the right, positive 13 kilogram meters per second, carried by a 3 kilogram object, so you do the division here, right, 13 kilogram meters per second divided by 3 kilograms. This is going to move off at 4.3 meters per second. That is pin equals pout. I'll do some more examples on the document camera. But it's really pretty easy. You figure out all the momentum coming in, add it vectorially. Now, this is an ultimately simple case. It's all along a number line. In the real world, things explode and they go off in 3 dimensions. But you would add up all the momenta on the x, all the momenta on the y, all the momenta on the z-axis, all 3 dimensional axes. You add those momenta up and you would do the same thing. It's a little bit, okay, it's a lot more complicated to do it in 3 dimensions, but the same idea all the way through. The momenta in x before the collision must equal the momenta in x after the collision. The momenta in y before the collision must equal the momenta in y after the collision, and so on with the z-axis. So these things really are made very simple by this idea of pin equals pout. The momentum coming into the system equals the momentum coming out. That's That's all there is to it. Thanks.